For the first derivative, we need to use the power rule. H prime of t is equals to 7 times 3, which is 21, and exponent 7 minus 1 is equals to 6. So we have 21t raised to the power of 6 minus 4 times negative 6 is equals to negative 24. Then the exponent of 4 minus 1 is equals to 3. So we have negative 24t raised to the power of 3 plus the derivatives of 8t raised to 3 is 3 times 8 is equals to 24. And exponent 3 minus 1 is equals to 2, so we have 24t squared. And now for the negative 12t, we have its derivatives, which is negative 12, and for the derivative of 18, we have to apply the constant rule, so the derivative of 18 is equals to 0. And for the second derivatives, we multiply 6 to 21, and then we subtract from the exponent, and the new exponent will be 5. Next, 3 times negative 24 will be negative 72. We subtract 1 from 3, that's why it is 72t squared for the last time, 24 times 2, and we get 48. Then we subtract 1 from 2, so no need to write the exponent. Then we discard negative 12 for the third derivatives. We will use the same process. This time, 5 times 126t, then we subtract 1 from the exponent 5 for the second term of the third derivative. 2 times negative 72 is equals to negative 144t, so no need to write 1 in the exponent because it is already considered. For the last term, we bring down 48 since there is a variable and we apply the rule of constant rule.
The given problem is f of x is equals to 4 fifth root of x cubed minus 1 over 8x squared minus square root of x. Convert radical into fraction and it will become 4x raised to the power of 3 fifths minus 1 over 8x squared minus x raised to the power of 1 half. For the first derivative, we need to use the power rule. F prime of x is equals to 3 fifths times 4, which is 12 fifths, and the exponent 3 fifths minus 1 is equals to negative 2 fifths. So we have 12 fifths x raised to the power of negative 2 fifths. For the second term of the first derivative, negative 2 times negative 1/8 is equals to positive 1/4. Then the exponent negative 2 subtract 1 is equals to negative 3. So we have 1/4 x raised to the power of negative 3 minus the derivative of x raised to the power of 1 half, which is 1 half copy x subtract 1 to 1 half, which is equals to negative 1 half. So we have 1 half x raised to the power of negative 1 half. And then, for the second derivative, we multiply negative 2 fifths to 12 fifths and then subtract 1 from the exponent, and it will be negative 24 over 25x raised to the power of negative 7 fifths. Next, negative 3 times 1/4 will be negative 3/4. then subtract 1 from negative 3, and it will become negative 4. So we have negative 3/4 x raised to the power of negative 4. For the last and for the third derivative, we will use the same process of this time. Negative 7/5 times 24/5 is equals to 168 over 125. Subtract 1 from the exponent and it will become negative 12/5. For the second term of the third derivative, negative 4 times negative 3/4 and subtract 1 from the exponent and it is equals to positive 3x raised to the power of negative 5. And for the last term, negative 3/2 times 1/4 and subtract 1 to negative 3/2 is equals to negative 3 over 8 x raised to the power of negative 5/2, and that is our third derivative.
Find the second derivative of q of t is equal to secant 5t. The derivative of secant is secant x tangent x. For the first derivative is q prime t. We need to bring down 5, then secant times 5t tangent 5t. So the first derivative is 5 secant times 5t tangent 5t. For the second derivative is 25 secant 5t tangent squared 5t plus 25 secant cube 5t, and that is the second derivative.